warm welcome to everyone joining us today. I hope you're having a fantastic day so far. We're thrilled to have you with us as we delve into the transformative role of DDI solutions as the foundation for data center networks. We'll see how these solutions unlock the potential for next generation data centers by delivering streamlined network management, enhanced scalability, and superior performance. We live in an age where rapidity drives revenue. Seamless real time performance is no longer just a competitive advantage, it's essential for success. Data centers play a pivotal role in ensuring low latency, scalability, reliability, and security for real time applications. From instant cloud access to flawless video calls, real time applications are propelling businesses forward. As the demand for instantaneous digital experiences continues to rise, advanced high performing data centers are more critical than ever in powering business success. In this webinar, we'll dive into how DDI solutions empower distributed data centers to deliver real time performance. You'll discover how they enable high availability, elastic scalability, centralized visibility, and advanced security, all while simplifying network management through policy driven automation. So let's get started. Before we move into the presentation, I'd like you to confirm in the webinar chat panel if you could hear me and see the presentation. You can also shoot out your questions in the webinar chat panel. Our team could give you prompt answers. Please post your questions at the end of the session if you'd like me to answer your questions live. A very quick introduction. I'm your host, Akshara GJ, product expert from ManageEngine. I collaborate closely with the marketing teams for ManageEngine, DDI Central, and Cloud DNS. A big part of what I do is talk about the critical network services like DNS, DHCP, and IPAM. I'm here to share insights on how DDI solutions can significantly optimize data center network infrastructures. Have an exciting agenda lined up for you today. We'll begin by understanding the evolving demands of modern distributed data centers where agility, performance, and security are paramount. Next, we'll discuss how to establish scalable data centers and disaster recovery sites to ensure business continuity under any circumstances. Moving on, we'll uncover the strategic importance of segmenting data center networks to enhance security and operational efficiency, protect critical assets, and optimize resources. Also, we'll explore how to ensure resiliency with built-in automated failover configurations so your operations stay uninterrupted even during unexpected failures. Additionally, we'll show you how policy-driven IP network automations for each data center site simplify network management and improve accuracy. Moreover, we'll dive into how utilizing real-time monitoring can help detect security threats proactively and enable effective capacity planning to meet growing demands. Further, we'll show you how to simplify server deployment with automated distribution of boot files using PXE configuration, saving time and reducing manual efforts. Finally, we'll cover how to build self-defending data center networks with multi-layered security, leveraging DNS Firewall policies for advanced threat detection and response. Did you know that data center networks are facing some of the most sophisticated and costly cybersecurity threats to date? As we approach 2025, the stakes are higher than ever. Insider threats are responsible for a staggering 55% of data center breaches, costing organizations an average of $700,000 per incident. Whether accidental or intentional, these incidents underscore the importance of role-based access controls and continuous monitoring. Ransomware attacks are a persistent menace. In 2024, the average cost of a ransomware incident has surged to $2.73 million. New variants like Viper ransomware and extortion via data leaks make robust backups and proactive defenses more critical than ever. Distributed denial of service or DDoS attacks are hitting unprecedented scales. The largest recorded attack peaked at 1 terabyte per second, with an alarming 15.4 million incidents reported in 2024, often driven by unsecured IoT devices. Emerging AI powered threats are changing the game. Hackers now use generative AI for creating deepfakes, phishing emails, and even simulating sophisticated attacks. Combating these requires advanced security protocols and early detection systems. While digital threats dominate headlines, physical security risks remain significant. Remote threats, perimeter breaches, and even on site vulnerabilities demand multi layered defenses and robust access controls. So, what's the takeaway here? Data center security is no longer optional. It must evolve to keep up with these escalating threats. Proactive strategies, advanced technologies, and robust compliance frameworks are essential to stay ahead. Let me ask you, are your defenses ready for 2025? Take a moment to reflect on your current security measures because securing your data center for the future starts today. Let's explore the critical challenges faced by modern distributed data center networks. These challenges reflect the evolving needs of businesses that rely on real time applications, scalable infrastructures, and secure operations. Each of these demands represent a significant problem to solve, and in this session, we'll discuss how DDI solutions address them. Modern businesses demand real time data transfer and synchronization across distributed data centers. However, achieving fast and reliable connectivity while minimizing latency and ensuring data consistency remains a significant challenge. With workloads evolving unpredictably and user demands increasing, distributed networks struggle to scale and adapt dynamically. Networks must handle unpredictable traffic spikes and quickly provision resources to meet changing application requirements. Routine tasks such as provisioning, scaling, and monitoring can be time consuming and prone to errors when performed manually. This inefficiency often leads to delayed service delivery and reduced operational agility. Lack of centralized visibility and control over distributed network resources results in misconfigurations and inefficiencies. Without a unified view of core network services, maintaining a structured IP address plan, or managing the resources of distributed data centers within a common IP infrastructure and ensuring consistent operations becomes extremely challenging. Proactively identifying threats and optimizing network capacity require real time insights. Many organizations struggled with delayed or incomplete monitoring, leaving them vulnerable to security risks and performance bottlenecks. As regulatory requirements grow, the inability to maintain detailed logging and reporting for audits and compliance checks put organizations at risk of penalties and reputational damage. Comprehensive accessible logs are now a necessity, not a luxury. Each of these demands reflects a critical challenge faced by modern data center networks. Throughout this webinar, we'll show you how DDI solutions enable faster, smarter, and more resilient data center operations. Let's take a closer look at the image on screen. This diagram illustrates the network architecture of a data center, DC LAN on the left, and its corresponding disaster recovery site, DR LAN on the right. These two environments are seamlessly interconnected through point-to-point or P2P links, enabling high availability, redundancy, and secure mission-critical IP communications between the two sites. Starting with the DC LAN, or we see the core network components driving the application and data processing, such as load balancers that distribute traffic efficiently, application servers that hosts business critical applications, database servers, ensure data availability for all operations. Now, notice how the DC side connects to the DR side through a series of point to point links. These links form the backbone of connectivity between the two sides, ensuring real time synchronization and seamless communication. Moving to the DR LAN, you'll see a mirrored setup of the DC. The same components are in place to provide a fully functional backup site. This interconnected structure ensures real time data synchronization between the DC and DR, failover capabilities in case of any disruptions, high availability, ensuring business continuity without interruptions. At the core of both DC LAN and DR LAN lies the LAN fabric, serving as the central backbone interconnecting all devices within each data center facility. This LAN fabric facilitates seamless communication across devices, switches, and servers. It creates a single logical network, ensuring consistent communication regardless of the physical topology. It serves as a foundation for a unified, scalable, and flexible network architecture built to enhance efficiency, manageability, and performance. However, managing mission critical IP communication within and across the LAN fabrics presents a key challenge. To ensure dynamic and efficient traffic routing, the LAN fabric and all its associated components within each site must converge under a structured, cohesive IP address plan. This requires replacing statically provisioned IP addresses, which are rigid and operationally expensive, with policy driven automation to assign unique IP addresses to each component dynamically. In modern data centers handling real time use cases, application traffic often traverses diverse parts of the network. Static provisioning hampers scalability and agility. With logical IP network automation, mission critical IP communications can be streamlined across LAN fabrics, ensuring dynamic routing of traffic within and across data centers, efficient interconnectivity between the primary DC and the DR side, flexibility and scalability to adapt to the growing demands of data center workloads. Main challenge is to unify the LAN fabric under a cohesive IP address plan driven by intelligent automation. This ensures seamless and interconnectivity, high availability, and efficient traffic management, laying the foundation for future growth and enabling data centers to support real time operations effortlessly. By addressing these challenges with modern DDI solutions, organizations can create programmable, scalable IP networks that drive efficiency, resilience, and innovation across interconnected data centers. Let's explore how a DDI solution makes this possible. So, what is DDI? A DDI is a specialized network management solution that provides a unified management console for the three core network services: DNS, DHCP, and IPAM. It enables you to take complete control over your DNS and DHCP clusters and gain holistic as well as deeper visibility into the configurations of these three services. With a DDI solution, you can easily define and manage scopes, dynamically lease IP addresses to hosts, set up custom DHCP device fingerprinting policies, manage DNS zones, zone scopes, and records, set up DNS security policies, analyze DNS query traffic, review audit logs, manage dual stack IP address inventories of your network, all through a single window. How can ManageEngine help you? ManageEngine has its own DDI solution called ManageEngine DDI Central. It is a user-friendly, specialized solution that unifies DNS, DHCP, and IPAM into a single platform for improving operational efficiency and network stability. It manages your existing Linux-based ISC Bind9 and ISC DHCP installations and can also set up new clusters. It can also manage your Microsoft Windows DNS and DHCP clusters. Throughout this webinar, you will see its tools and features being highlighted to witness a DDI solution in action. What if I told you that this one window solution can also serve as a single point of management for all the interconnected data center networks of any modern distributed data center? Yes, with a DDI solution, you can easily manage the DNS, DHCP, and IPAM configurations of each data center site that is already connected to your organization's main network using advanced technologies like SD-WAN, IP/MPLS core via VPN, or even dark fiber cables. As you onboard all your DNS and DHCP servers of a data center facility as a cluster into DDI Central, it starts discovering all the configurations on a granular level to consolidate, catalog, and correlate the configurations, facilitating a contextualized visibility. With all the configurations organized in its UI, you can easily control your core network services and make required amends to them. Analyze the rich visual analytics that accompany each module to get quick visual snapshots to arrive at valuable actionable insights that quicken troubleshooting. This way, your data center network administrators can holistically view and centrally manage the core network services of distributed data center facilities spread across the globe, all from a single window. See how this is possible with ManageEngine's own DDI solution, DDI Central. So in DDI Central, you can manage each data center facility as a separate cluster. Depending on their operating system, Linux or Windows, each cluster comes with its own internalized IPAM, its own IP address inventory, DNS manager, DHCP manager, and can be managed independently of other clusters. All you have to do is add and manage the DNS and DHCP servers of each data center to each cluster and discover their configurations and manage them from a unified window. You can just choose the cluster of your choice and monitor the health and performance of its core services in real time. So, this is how you can seamlessly scale as your distributed data center network facilities grow using DDI Central. Let us now focus on a crucial defensive strategy in network management: network segmentation. This adds another layer of protection, partitioning the enterprise network into manageable, secure segments to reduce the attack surface, limit data exfiltration, and reduce the scope of audits and compliance. Network admins can separate servers and endpoint devices based on the line of business which they belong, like introducing separate segments for consumer banking, commercial banking, investment banking, capital markets or trading, institutional asset management, IoTs, and more. A host in a retail bank branch would not need access to investment banking servers in the data center, and vice versa. Segmenting a data center's network is not just an operational tactic, but a strategic necessity in today's cybersecurity landscape. Segmentation begins with analyzing normal traffic patterns for applications on the network. This approach allows for logical grouping of devices and systems, ensuring that each segment is tailored for the specific communication needs and security requirements of the application it supports. Let's have a look at the diagram on the right side of the screen. For instance, take a scenario where users access a specific application. To improve both performance and security, we can place the application server and the database server within the same subnet, ensuring that all related traffic is localized and flows efficiently without crossing unnecessary network boundaries. Here, users accessing the application, whether from a smart device, PC, or mobile phone, interact with the application server. The application server, in turn, communicates seamlessly with the database server within its subnet. This configuration minimizes latency, improves data retrieval times, and reduces the risk of unauthorized access. By keeping the application and database servers within a dedicated subnet, you also gain an added layer of security. External traffic passes through the firewall and reaches the application server, but access to the database server is restricted to traffic originating from within the subnet, preventing direct external access and safeguarding sensitive data. This approach ensures efficient resource utilization by reducing unnecessary network hops, streamlined communication between application components, improved performance for end users by reducing latency, increased security by restricting database access to trusted sources. Logical grouping through segmentation not only optimizes your network for performance, but also reinforces security and compliance essential for today's interconnected data center environments. So let's focus on the diagram on the left side of the screen. Network traffic flows in two primary directions. North-south traffic, this includes communication between external zones like retail bank branch zone and internal data center resources such as consumer banking data center zone. East-west traffic, this involves traffic within the data center such as communication between corporate servers in the corporate data center zone and endpoints in the corporate endpoint zone. Segmentation enforces permissible traffic flows while isolating unauthorized access. For example, traffic from the retail bank branch zone is permitted to interact with the consumer banking data center zone, but is restricted from accessing the corporate endpoint zones. Similarly, traffic between the corporate data center zone and corporate endpoint zone is tightly controlled, ensuring that the sensitive data and systems remain secure. This approach creates clear boundaries between different segments, ensuring that retail banking operations function independently from corporate workflows. End user devices are restricted to accessing only authorized resources. Data centers are protected from unnecessary or malicious traffic, enhancing overall security. With intelligent network segmentation, data centers can achieve better security, optimized traffic flow, and improved operational efficiency. This ensures that every connection is purposeful, secure, and aligned with organization goals. Let's see how DDI Central simplifies defining and managing these scopes. So we have something called DHCP Scope Manager. So with the DHCP Scope Manager, you can define scopes like subnets, supernets, shared networks, and VLANs. Client class is basically DHCP policies that would help you define policies that helps you identify a particular client in your network. So subnets are the basic building blocks of your DHCP scopes, and shared networks is a collection of subnets put together. And with a collection of subnets, you treat them as a single entity and you can apply collective policies. So supernets are basically are used for hierarchically organizing your subnets. So you have a list of subnets over here. So if you would like to introduce a hierarchical order, you can create the relevant supernets and organize all these bundle of subnets under a particular defined supernet. So let's see how you can configure these subnets, supernets, shared networks in DDI Central. So for configuring a subnet, all you have to do is provide a network address, a network prefix, and associate it with a particular DHCP server. If you'd like to enable failover services, you'll have to enable failover DHCP and specify the secondary DHCP server. And you can, for the scope of this particular subnet, you can assign it on a global level, or you can assign it under a particular shared network. To introduce hierarchy among the defined subnets, you can also assign it under a particular supernet. So, and now if you'd like to build a VLAN on the top of this subnet, you can provide the VLAN details, or you can just enable this toggle to assign it to an existing VLAN. And here comes the pool data. Here you'll have to declare the IP range within which this subnet should actively provision IP address to the particular host joining its network. So the DHCP server will choose, based on the policies, it will select the clients that satisfy a particular criteria based on the policy, and will choose IP addresses between this range and allot it to the clients that satisfy the criteria. So that's how the subnets are created. Shared networks are a bunch of subnets put together. So you can see how the subnets are mentioned over here, and you can assign DHCP options collectively. And host configurations are nothing but DHCP reservations, where you mention the MAC address of the device that you'd like to add DHCP reservation for, and you assign the fixed IP address for that particular device. And you can assign it on any level, whether it's going to be on a global level, subnet level, shared network level, or you can assign it under a host group, which is nothing but a collection of hosts put together. So yeah, that's how you configure DHCP scopes in DDI Central. Let's see how IoTs are managed in data centers. IoT and smart infrastructure are revolutionizing the way data centers operate, from monitoring environmental conditions like temperature, so environmental conditions like temperature to managing power efficiently. IoT devices have become a critical component of modern data center ecosystems. As IoT devices play an increasingly integral role, managing their IP communications efficiently has become a top priority. Data centers handling IoT devices for tasks such as environmental monitoring require seamless and reliable IP address management to ensure stable operations. This is where DDI solutions step in to make a difference. For 24 cross 7 surveillance devices like CCTV cameras that cannot tolerate any disruptions or delay, fixed IP addresses are assigned to ensure stable and secure communications without interruptions. For IoT devices that activate based on event driven policies, example smart door locks, thermostats, and lighting systems, IP addresses are dynamically provisioned. Abandoned or unused IP addresses here are reclaimed automatically, preventing address exhaustion in IoT heavy environments. Using VLAN aware DHCP policies, IoT traffic is isolated from data centers' core network traffic, enhancing security and minimizing resource conflicts. What we get is a reliable IoT infrastructure that ensures optimal data center performance while maintaining robust security and avoiding resource conflicts. With DDI solutions, data centers can fully leverage the power of IoT, combining efficiency with security. Let's see how VLANs are configured in DDI Central. So configuring VLANs is quite simple. As we mentioned before, VLANs are built on the top of subnets. All you have to do is enter the relevant VLAN details by creating a new subnet or opening an existing subnet. And if you have an existing VLAN, all you have to do is enable this toggle. This will assign the particular subnet that you've chosen to a targeted VLAN that already exists in your network. So on creating a new VLAN, you get to access all the IP address inventory within the particular VLAN, which is the subnet that is being associated to that particular VLAN. With DDI Central, you can define and implement VLAN-aware DHCP policies to seamlessly integrate IoT devices while isolating their traffic from the rest of the data center network. So let's break down how this works. So we'll start by defining a DHCP policy specific to a VLAN. So in DDI Central, we can define a policy associated with the subnet on top of which the targeted VLAN is configured. Further, the policy is assigned to a DHCP server, and along with the scope within the DHCP server, whether it's going to be on the global level or within the subnet level configurations. You can also customize the lease duration based on your requirements, setting it to limited or unlimited duration for the IoT devices targeted by the policy. And you can associate multiple advanced conditions together with the relevant conditional operator to further refine how IP addresses are allocated within a VLAN. With DDI Central, configuring and managing VLANs becomes seamless, providing a centralized approach to achieving an organized, secure, and efficient infrastructure tailored for IoT integration. So now that we've configured subnets and all the scopes available in DDI Central, when the configured subnets are viewed under the IPAM module in DDI Central, we can efficiently monitor them. So this is how the configured subnet would appear in the IPAM module. So you can see the entire IP address inventory within that particular subnet. As we delve deeper into a specific subnet in IPAM, a donut plot provides a visual breakdown of the number of IP addresses in the subnet according to their availability status. These visual snapshots assist administrators with effective capacity planning and alert them at utilization thresholds. In the event of an IP address conflict within a particular subnet, the admin can click on any available or free IP and directly assign it as a fixed IP address to one of the conflicting hosts until subsequent remediation. This way, admins have hands on control over the IP address inventory within a subnet. In this slide, we see a simplified example of how service segmentation or split horizon DNS is achieved using DNS domain views. We'll walk you through the process step by step, highlighting the distinction between internal and external views for zones under the domain name zilkabanks.com. So let's see what are DNS views first. DNS views is a special feature through which you can implement service segmentation using DNS servers. It resolves names to IP addresses, controlling which resources are discoverable within each segment. Split horizon DNS can restrict name resolution visibility to specific segments, reducing the attack surface. It enhances protection against potential threats by customizing DNS responses, enforcing distinct security policies, and controls access for different user groups and network segments within your organization. Attackers scanning for services or open ports will find fewer exposed resources, reducing their opportunities for lateral movement. So here in the image, we see a client initiate a query for debitcards.zilkabanks.com under the domain name zilkabanks.com. This request is sent to the DNS server to resolve the domain name into an IP address. Upon receiving the query, the DNS server first checks the client's IP against the internal match list. The internal view match list contains only IP addresses of registered employees who are involved in guiding debit card application processes. In this scenario, the client's IP is not found in the internal view match list. Since the client IP is not in the internal view, the DNS server then checks the external view. The external view match list has no IP restrictions and resolves queries for any client IP. This view is used to provide a version of debitcards.zilkabanks.com that only offers generic information to external visitors inquiring about Zilka Bank's debit cards. The server confirms that the query for zilkabanks.com should be handled under the external view. It locates the requested zone under the domain name zilkabanks.com and directs the client to the appropriate resource. The IP address returned by the external view is different from the internal one, ensuring that only public, non-sensitive information is accessed. Finally, the DNS server sends the appropriate response back to the client, and the client then proceeds to access the resource. In DDI Central, we have a special page called the Analytics page where you can see who has accessed what domain DNS resource. So if you have any views configured, any block domain, any domains hosted in your network, you can see who in your network with their IP address has been accessing this particular domain and how many number of queries they've been making. So you can see the hourly number of total queries handled by this particular domain name and how many queries and the visual breakdown of the number of requests handled by hello.com. And you can see the type of records accessed, requested for under hello.com. So this is also available for views. So you can also view the similar stats for the views configured as well. DDI solutions offer comprehensive built-in logging and reporting capabilities that aid in compliance with regulations like GDPR, Sarbanes-Oxley Act of 2002 or SOX Act, and more. Any portions of the network that warrant special consideration due to audit or regulatory concerns should be prioritized. To reduce the scope of PCI DSS compliance audits, network segmentation of the resources that handle cardholder data is particularly effective. By ring fencing all relevant components, the audit does not need to expand beyond the confines of this network segment. By reducing the breadth of audit trails through compartmentalizing related resources on the network, this minimizes the time and effort needed to satisfy such an audit. DDI Central captures audit trails for every action executed on each and every object managed by the DNS and DHCP servers. You can choose the relevant subnets or zones and report audits of only those segments to the regulators. This saves time and reduces costs compared to reporting full network audits. Now let's see how DDI Central implements auto failover setups for DNS and DHCP services. In DDI Central for DHCP servers, while configuring a subnet, you can add one primary DHCP server and one secondary DHCP server. In case the primary DHCP server fails, the secondary DHCP server comes to the fore and handles the entire traffic. If you want these servers to split the load, and you can enter the relevant value in the split field. A value of 128 here indicates 50-50 load balancing, actively involving both primary and secondary servers to handle the DHCP traffic. For the DNS servers, while configuring a domain, you can add multiple primary DNS servers for the domain. So it's here you add all the multiple primary DNS servers. Subsequently, DDI Central also accepts a list of multiple secondary servers to facilitate reliable access to resources across a data center network. The DDI solution in place, data from all the three core network services are not only collected but also correlated and analyzed in one central hub. In a DDI solution like DDI Central, IPAM serves as the centralized and contextualized network source of truth that maps upstream relationships among the core services. As you can see in the image, behind the lease history of a particular IP, you get to see how it has captured and correlated rich IP metadata like DNS records, DHCP lease information, and address allocations of various hosts within the network. This unified approach allows for a holistic view of network operations, enabling data center network admins to make timely and informed decisions based on comprehensive data analysis. This information aids in quickly troubleshooting network issues, optimizing resource allocation, and maintaining network stability. With these three core services in sync with each other, DDI serves as a sophisticated automation hub as it becomes easy to set up end-to-end automation involving these services. So here are some of the key processes that can be automated using a DDI solution. Using a DHCP server, you can automatically assign IP addresses to hosts on the network. This enhances the efficiency of network resource management and ensures that IP addresses are reclaimed, reused appropriately, reducing wastage and preventing address exhaustion. DNS is essential for mapping domain names to IP addresses across the DC and the DR. The dynamic DNS feature automatically updates DNS records when IP addresses change, ensuring network resources remain accessible via their host names. A DDI solution streamlines this process by automating DNS updates whenever new servers, subnets, or applications are added. This eliminates the need for manual intervention, ensuring smooth connectivity. Such automation is critical in data center networks where frequent device mobility and configuration changes require real-time updates. DDI system automatically detects and resolves IP conflicts and maintains an updated IP address inventory, ensuring reliable connectivity and preventing downtime in data center operations. Scheduled creation of DHCP scopes and DNS records allow network administrators to go on a schedule it and forget it mode, enabling them to plan and implement network expansions or updates at predetermined times for maintaining uninterrupted service during operational hours. Scheduled DNS and DHCP report from time to time gives admins a real-time snapshot of subnet capacities and zone query analytics for strategic resource planning of your network. Let's see how to combat cyber threats using DDI Central. The DDI solutions follow, in general, a defense in depth security philosophy, erecting multi layered barriers to prevent or combat against the increased sophistication of advanced persistent threats and the multiple attack vectors facing data center networks. Let's look at the different types of mitigation strategies based on their level of persistence of the cyber attacks targeting the data centers across various industries. As DNS is the first point of contact across external networks, the DNS firewall constitutes the network's first line of defense. Following a layered approach, it imparts self defending capabilities to networks by placing strategic defenses against unwanted intrusions. It actively blocks malicious activity using domain blocking and mitigates ongoing attacks with its response rate limiting policies. So let's see how DNS firewall works. Let's consider a scenario where an employee of your organization has clicked a link within a crafty phishing email and unknowingly gets his or her system infected by malware. Upon connecting to your institution's private network, the malware tries to covertly access malicious sites using your DNS resolver. DDI Central easily manages such situations with its DNS firewall. This firewall maintains a blacklist comprising a recognized collection of undesirable domains. Before the resolver can provide the actual IP address, it checks the domain against the blacklist. If there is a match on the blacklist, the resolver does not proceed to fetch the real IP address from the external authoritative DNS server. Instead of connecting to the malicious site, it redirects the user to a safety page. Let's see how this is configured in DDI Central. Using DDI Central, you can configure the DNS sinkhole settings for all the DNS clients in the cluster at global or universal level. So all you have to do is add the domain names that you'd like to block one by one, or if you have a huge list, you can import them into DDI Central using a CSV file. So we have a list of undesirable domains for under various categories. So you can choose the ones relevant for your industry and you can directly import them into the block list. And if you're not sure about the number of subdomains under the particular domain name, you can check this, select this checkbox. So this will block all the hidden subdomains under a particular malicious domain name. And if you're adding a new domain and if you'd like to create a new category, you can click on the add icon in the right corner. So the very crucial part here is entering a redirection IP. So whenever a client in your network is trying to access any block domain within this block list, they'll be redirected to this particular IP. So you can have a safety page or a warning message under this particular IP. So they'll be directed to this safety page. So whenever a malware is covertly accessing any malicious domain, you'll be you'll be needing information about which particular device is accessing this particular malicious domain. So in order to detect that, you can get into the analytics page. Here, the analytics page will provide DNS and query analytics for block domains. So you can choose the block domain of your choice, and there you'll get essential information like which IP has been accessing this particular domain name and what record type has been accessed, and the host name or the MAC address of that particular host assigned to this particular IP address would be displayed over here. So this way you can circle out the end device that was accessing the particular block domain under the particular time period. So this way you can quarantine that particular endpoint or the host device from the rest of the network. Let's dissect a common cyber attack scenario involving a botnet and discuss the defensive strategies that can be employed using a DDI solution. At the core, we have the botnet command center targeting a particular victim network in your data center network. It keeps sending instructions to compromised endpoints called botnets. These botnets then execute the attack by sending malicious queries to the DNS servers using the IP address of the victim. This is known as IP spoofing. The DNS servers in your data center network, unaware of the deception, respond to these queries. However, due to the nature of the attack, these responses are not just simple replies. They are massively amplified, meaning a small query triggers a large response. The final target of this onslaught is the victim network in your data center facility. The amplified responses flood the victim's network, potentially overwhelming it with data and causing significant disruption. This type of attack is known as distributed denial of service attack or DDoS attack. These threats can be instantly identified using DDI Central's query analytics tool that visually charts unusual spikes in hourly query traffic, indicating a DDoS attack in progress. Mitigate an ongoing DDoS attacks, DNS servers can be configured to limit the response rate to any individual IP address. This way, it prevents the DNS servers from being used as amplifiers in DDoS attacks and further prevent the movement of malware from compromised end-user systems to more sensitive and data center resources. The response rate limiting is a DNS security feature that intelligently regulates response throttling to mitigate the impact of DNS amplification attacks, ensuring uninterrupted access for legitimate clients and upholding a well balanced approach to security. It facilitates a selective response mechanism that ensures your network is not only resilient against attacks but also remains efficient and reliable for legitimate users. So in DDI Central, RRL does not just limit the number of identical responses per second from a single IP address or subnet, it also limits the number of variety of DNS responses per second. You can also define how broadly rate limiting is applied across different IP ranges. It also enables you to specify the trusted clients that are exempt from rate limiting. By configuring these options, administrators can significantly reduce the impact of DNS based amplification attacks, ensuring a more secure and reliable network. So this is how response rate limiting is configured for Linux-based ISC binary servers. For Windows-based DNS servers, the response rate limiting configurations are set using this particular configurations, and you can also exempt the trusted clients by assigning different conditions, and only if they satisfy the conditions specified in the exception list, they'll be exempted from the rate limiting policies. Cyber attackers need to move freely through a network to identify items of value. Network segmentation is a critical element of an overall cybersecurity strategy that reduces the risk and impact of attacks during the occurrence of a breach. By segmenting a network into segments or scopes, you isolate each segment from the rest of the network. Each segment establishes an isolated broadcast domain with the DHCP server. By taking this pragmatic approach, your organization can minimize business disruption and reap benefits such as limited exposure after an intrusion and reductions in the lost productivity, remediation costs, and reputational damage from the actual loss of personal identifiable information, PII, or other critical data. Network segmentation is only a part of DDI Solutions' layered security philosophy, enabling data centers to survive intrusions and minimize or even prevent successful data breaches. In the end, This allows for a speedy return to business as usual. Segmenting the scopes into segments and VLANs, subnets and VLANs help contain the damage by isolating the affected segment, allowing administrators to more effectively control the spread and mitigate risks. Subnet, Subnetting also reduces network-wide threats by quarantining compromised areas and hindering unauthorized lateral movement within the unaffected network. So here's an interesting use case. A tech company's interconnected data centers require an agile infrastructure to support rapid provisioning of development and testing environments. For DevOps teams, the ability to quickly set up, deploy, and tear down environments is crucial for maintaining high velocity and adapting to rapidly changing development needs. However, achieving this level of agility comes with several challenges. Traditional methods of manually assigning IP addresses and configuring DNS records for new development and testing servers are time consuming and error prone. Delays in provisioning can bottleneck the development lifecycle, slowing down testing cycles and overall product delivery timelines. In environments that rely on physical servers for certain workloads, onboarding bare metal servers often involves complex configurations and manual intervention. This slows down the creation of new test environments, especially when dealing with multiple data center sites. It also increases the risk of misconfigurations, leading to operational inefficiencies. Without centralized visibility, tracking resource usage such as IP addresses, server allocations, and DNS configurations across interconnected data centers becomes nearly impossible. Inefficient resources allocations leads to over-provisioning, underutilized resources, or conflicts in IP assignments. This can result in downtime or wasted resources. The number of development and testing environment increases, maintaining scalability becomes difficult. Static processes and tools struggle to keep up with the dynamic DevOps workflows. Organizations fail to meet the demands of large scale testing and deployment pipelines, which slows down innovation and product delivery. What's the solution here? How DDI Central addresses these challenges? Zero touch provisioning automatically configures IP addresses and DNS records for new servers, eliminating manual intervention. This speeds up the provisioning process, enabling DevOps teams to quickly deploy development and testing environment. Pixie Boot templates automates the onboarding of bare metal servers with pre-configured templates for rapid setup. This reduces onboarding time and ensures consistency across environments, particularly for testing large-scale applications. DDI Central's unified UI provides real-time tracking of IP addresses, DNS records, and record usage across data centers. This ensures efficient resource allocation, prevents conflicts, and scales effortlessly as the DevOps needs grow. Proactive network management through advanced scheduling of DNS objects and DHCP objects ensures that the network changes occur exactly when needed without manual intervention. So let's see how these features are configured using DDI Central. So for automated provisioning of IPs using DHCP policies, you'll have to specify, name your policy and assign it to a particular DHCP server. And you mention the scope of your policy, whether it's going to be on a universal global level or it's going to be restricted, limited to a particular subnet. And then you mention if it is going to be under a particular subnet, applicable for a subnet, you will have to mention the subnet and the IP range that will be provisioned if any host satisfies the criteria within the policy, and the custom lease duration associated with the policy. And you'll have to specify the conditions one by one. And if you have multiple conditions, make sure you associate them with a conditional operator. And you can designate different DHCP options and custom options. And you can also customize the DDNS settings for this particular policy. So if any client in your network satisfies the conditions mentioned over here, it will be assigned IP addresses from this range. Achieve zero touch provisioning of bare metal servers, we incorporate PIGZ configurations or pre boot execution environment configurations. With the PIGZ configurations, the DHCP server does all the heavy lifting in provisioning boot files, configuration files, or even firmwares as soon as a bare metal server connects to the network. This can include lightweight operating systems, specific security updates, and customized applications designed for minimal resource consumption and rapid boot times. Using PIGZ configurations, the DHCP server directs the bare metal server to the TFTP server in your network. TFTP server ensures that these files are centrally managed and deployed, significantly simplifying the process of updating and maintaining a large fleet of bare metal servers scattered across different locations in your network. As you can see on the screen, we've created a template first with the conditional criteria. So we'll pass through a DHCP packet and we'll search for the vendor profile information. So we've specified the offset and the length along which the vendor profile details can be extracted, and you specify the match value. So here's the architecture code or the vendor code. So when a particular device matches through this substring criteria, it is then directed to the TFTP server whose IP address is given over here. So once you've given entered the details for the template, you can associate this template to a client class. So all the values that are given in the template will be imported directly into the client class, and you'll have to select the template that you'd like to associate with a particular client class. So it is the TFTP server that gives the relevant boot files. All this can be automated by your DHCP server for hundreds and thousands of bare metal servers as soon as they are plugged into your network without any manual intervention. This is actually a one-time configuration. You don't have to repeat it for every set of new devices joining your network. Configure it once with these instructions in place. Every time a new bare metal server is plugged into your network, the targeted configurations would be applied for that server. So let's see how scheduling is configured in DDI Central. All you have to do is enter all the necessary data for the subnet and or any scope that you're targeting and choose the optimal date and time for the subnet or the scope to be scheduled. On clicking save, you finalize the configurations. Whether you create a subnet on schedule or update the configurations of an already existing subnet on schedule, you can see the subnet with a clock icon beside it, indicating it has scheduled configuration set to activate on the designated date and time. You can only modify the schedule or delete these scheduled configurations, but cannot update the configurations within the subnet set on the schedule. All the configurations within a scheduled subnet will be locked until the schedule is activated. So, following the same procedure, network admins can schedule shared networks, DHCP policies, VLANs, and all types of DNS records. By automating the activation of DNS and DHCP objects, network administrators can focus more on monitoring and optimizing the network performance during critical periods rather than managing routine tasks. This is crucial in dynamic environments where conditions can change rapidly and the demand on network resources can vary significantly. Network resources are managed efficiently, ensuring they are available when most needed without permanent expenditure on extra capacity. By scheduling the activation of DNS and DHCP objects according to expected demand patterns, businesses can create a flexible, responsive IT infrastructure capable of supporting diverse and demanding project requirements with ease. So, what's the outcome? Streamlined DevOps operations are achieved for the tech company. Rapid provisioning of resources reduces the time required to set up new development and testing environments. This allows developers to focus on coding and testing rather than waiting for infrastructure readiness. Automation minimizes manual configurations, reducing errors and ensuring consistent network setups. Streamlined workflows align with agile methodologies, enabling faster iterations and delivery cycles. Centralized visibility ensures that the scaling resources for new projects or teams is seamless and efficient. Dynamic allocation of IP addresses and DNS configurations support the rapid growth of DevOps streams and workloads. A DDI solution bridges the gap between IT operations, development teams, fostering better collaboration and alignment with DevOps principles. By leveraging a full stack DDI solution, the tech company achieves a robust automated data center network infrastructure that supports its agile DevOps operations. This enables faster deployment, streamlined workflows, and quicker product deliveries, which is a critical advantage in today's fast paced technology landscape. As we conclude this webinar, let's focus on how a full stack DDI solution redefines the way we manage IP networks in distributed data centers. At its core, the IP network serves as the scaffolding for data center operations. It enables seamless communication by assigning unique IP addresses to every device, allowing them to exchange information and power the connectivity that drives businesses forward. This network is the foundation of a data center's digital ecosystem, ensuring smooth interactions between devices, applications, and users within the data center and across interconnected data center sites. In today's competitive and fast paced data center landscape, programmable IP networks have become a game changer. They are essential for maintaining connectivity, driving operational efficiency, improving service quality, and enabling businesses to remain agile in adapting to evolving demands. Today's competitive landscape, programmable IP networks are essential for maintaining robust connectivity, enhancing operational efficiency, scaling services, and ensuring data centers can adapt to evolving business needs. These networks enable data centers to handle complex real time workloads with agility, reliability, and high precision. A modern DDI solution goes beyond traditional DNS, DHCP, and IPAM by integrating advanced capabilities like automation, real time analytics, enhanced security, and scalability. These solutions address the complexities of programming and managing IP networks while ensuring efficiency, reliability, and compliance with critical regulations such as PCI DSS and GDPR. By converging all the elements within a data center into a structured, policy driven IP address plan, DDI solutions allow you to build programmable, scalable networks that streamline communication across devices and applications, provide robust connectivity to handle real time demands, and maintain compliance and security in a fast evolving digital landscape. This cohesive approach empowers businesses to manage their distributed data centers as a unified, efficient, and agile infrastructure ready to meet the demands of real time operations, enhance customer experiences, and stay ahead of industry trends. Thank you for taking the time to be a part of this webinar. Right after the session, you'll be directed to our downloads page where you can start your 30-day free trial. You can also visit our demo page where we have a live interactive demo up and running for you to explore and play around with. If you have any queries, please shoot us an email at ddi-support@manageengine.com. This is your host, Akshara, signing off. Thank you.